For the column vectors x and y, calculate the column vector z, where z is equal to 2x minus 3y. And so our goal is to determine or to calculate the column vector z. And we have that z is equal to 2x minus 3y. So that means that wherever we see x, we're going to put this column vector. And wherever we see y, we're going to put this column vector. So let's substitute. So we have 2 times 15 and negative 8. And we have negative 3 times negative 3 and 4. And so what we do? Well, we multiply. We say 2 times 15. And 2 times 15 is 30. And we say 2 times negative 8. And 2 times negative 8 is negative 16. Now on this side, we haven't multiplied yet. The only thing that we did was we say, okay, negative 3 can be expressed as, we can express negative 3 as positive, this positive sign, and negative 3. And that makes sense because we know that a positive multiplied by a negative is equal to a negative. And you may be asking, well, what's the point of doing this step? Well, this step is helpful because it helps to emphasize two things. Number one, we know what sign we're going to use after we multiply the negative 3 by this factor. And two, it helps to emphasize the idea or the point that we are multiplying this vector by this negative 3. And so when we multiply this negative 3 by this vector, by doing the step, we know that the sign that's going to be between, the sign that's going to be left over is actually a positive sign. And so that's what this step is for. It helps to emphasize that, hey, when we finish multiplying this negative 3 by this vector, the sign that's going to be left over is not actually a subtraction sign. It's actually going to be a positive sign. And so that's useful. And it makes sense because a positive times a negative is still a negative. So we essentially broke down this negative and expressed it as a positive times a negative. And that's what a negative is, right? So we basically expanded in a way, we expanded this negative sign by saying, okay, we can take this negative sign and express it as a positive times a negative, but it makes sense because a positive times a negative is still a negative. And so that's cool. So we have negative 3, which is here, and we say, okay, negative 3 multiplied by this factor. And so we have negative 3 multiplied by negative 3. And negative 3 multiplied by negative 3 is positive 9. And we have a negative 3 multiplied by positive 4. That gives us a negative 12. And so we have 30 and negative 16 plus 9 and negative 12. And so we have 30 plus 9, and 30 plus 9 is actually equal to 39. And we have a negative 16 plus negative 12, and negative 16 plus negative 12 is negative 28. So z, the factor z, is equal to 39 and negative 28. Okay, so, and that's because a negative 16 plus negative 12 is a negative 28. Okay, let's move on to the next part of this question. It says, calculate the magnitude of x, the magnitude of x. So this is the vector x. And in general, if we're trying to figure out the magnitude of a vector, right, a column vector, how do we figure out the magnitude of a column vector? Well, that has two components. Well, in order for us to do that, all we need to do is we need to take the first component and square it, take the second component and square it, add that sum, and then take the square root of that sum. And that's basically what the formula is saying. If you want to figure out the magnitude of a column vector, all you need to do is take the first component and square it, take the second component and square it, add those two, right? And then when you add those two, you take that sum and you take the square root of that sum. And that's basically the formula for finding the magnitude of a column vector that has two entries. And so we're going to do that. So here we know that x is equal to 15 and negative 8. And so we evaluate the magnitude of this vector in the following way. So the magnitude of vector x is equal to first component, square it, second component, square it. So 15 squared is equal to 225, and negative 8 squared is equal to 64. And then we add those two, and we add them, we get 289, and then we have to take the square root of 289, and the square root of 289 is 17. So that means that the magnitude of vector x is actually equal to 17, and that's the answer to this question.